Worse or better, it just is.
Fair.
Victoria looks like she wants to interject something.
Yeah, well, we're at the top of the hour, and
Okay.
I guess we have a lot to discuss. That's already been great. So thanks everyone for coming, and I'm really excited. I'm just gonna introduce sort of the gist of this, and then we'll let Stephanie take it away. So. Hello, everyone watching this, and hello, panelists, and welcome to the Grand Challenges in Robotics panel. My name is Victoria Preston, and I'm a graduate student in the Robust Robotics group at MIT with Nick, and I'm also part of the Chemical Sensing Laboratory at Woods Hole Oceanographic Institution. I had the great fortune of organizing inclusion at CoRL this year with Mike Noseworthy and Catherine Liu. We're really excited to be kickstarting the Inclusion at CoRL initiative with this panel, and really appreciate everyone's participation. The intent of this hour is to have a dialogue about the who, what, why, and how of robotics research in the future. Who will conduct the research and for whom? What technical and logistical hurdles need to be overcome? Why certain applications or initiatives deserve our attention? And how will we get to this imagined future together? We hope to not only discuss these questions at a high level, but also identify tangible actions we can incorporate into our own research, labs, or institutions from here forward. This panel will begin with a structured, moderated discussion, followed by an open Q&A. So everyone participating in this webinar, please use the Q&A functionality to post questions. It'll be open throughout. Following this panel, we also invite everyone to come to a social event on Gather Town, which is posted on Feedloop to debrief and network with fellow attendees. So moderating our discussion today is Associate Professor of Computer Science at Brown University, Stephanie Telix. Stephanie, thank you so much for being with us today. And I'm going to hand it over to you to get us started. Thanks, everyone.
Awesome. So thank you so much for organizing this. I think these conversations are super important, and I think it's really cool that it's part of the main track at CoRL this year. And thanks to everybody else for participating despite the unusual format of the conference. So why don't we start by introducing so we'll have the panelists introduce yourself and say, where you are and a little bit about your research and the role that you see yourself playing in the robotics research community. And I'll start. So I'm a professor at Brown University, and my research is trying to make robots understand natural language commands. And I also work on a fairly large outreach program now where we give away drones to high school students and their teachers to try to increase the access to autonomous robots to schools at the high school level. So why don't we go to the panelists? So maybe Professor Hiram Pons, you want to go first? And I'm sorry if I'm saying your name wrong.
Don't worry, Stephanie. Thank you very much for the invitation. Hello to everybody. So my name is Hiram Ponce. I am an associate professor and researcher at the School of Engineering in the Universidad Panamericana in Mexico City, Mexico. This is quite the second top private university here. So I am currently leading the computational intelligence and vision research group. So I love to develop new methodologies around artificial intelligence, nature-inspired computing, intelligent control, and robotics in order to make technological solutions for social good and ambient assisted living. So currently I am working on developing a chameleon-like robot, getting inspiration from the biomechanics of this animal to solve complex and limited support regions for walking robots. So my main motivation for this research is to put into action the experience in rescue and maintenance robots. So I would like to create new tools and techniques for different disciplines involved here. So I am very pleased to be here.
Awesome, thanks for the introduction. And again, I apologize. I should have asked your names in the pre-game, but I did not. Dr. Yulia Sendemirskaya, and I'm again sorry I'm saying it wrong.
It's perfect, thanks. So I'm Yulia Sendemirskaya. I am a researcher at Intel in neuromorphic computing lab. So I've been developing for a long time now computing architectures for robots that are inspired by biological neural networks. So by the way, how the brain solves perception, control, movement generation, memory formation, all kinds of tasks. And by doing that, we're trying to do all aspects of robotics, from perception to motor control, with almost everything in between. So SLAM, object recognition, action understanding, human robot interaction, by its breadth, kind of a little bit of everything, but following this bio-inspired road. So developing neural network architectures to solve all those tasks. And typically these neural network architectures then run better on special neuronal or neuromorphic hardware, computing hardware processors. And this is what we also has been developed at Intel, and I can now work with this hardware.
Awesome, super exciting. Mark?
Hi, my name is Mark Dyson. I'm a professor at University College London in the UK. I told Michael when he invited me that I haven't actually done robotics in many, many years. So I'm a machine learner. So we are focusing on data efficient machine learning. That means learning from relatively small data sets. And you can do this in multiple ways, for example, through probabilistic modeling or transfer learning or various other ways. And that's the reason why robotics is actually quite interesting to us, because that seems to be a natural domain where collecting a lot of data is quite hard. So we are starting to actually work more on robotics again in manipulation, and yeah. So that's pretty much what's going on here.
Awesome. And Dr. Conrad Tucker?
Hello, everyone. I'm Conrad Tucker. I'm a professor of mechanical engineering at Carnegie Mellon, also affiliated with the Machine Learning Department and the Robotics Institute here at CMU. And my research focuses more on the AI side of things. We have been funded by the NSF National Robotics Initiative and DARPA, among other agencies. And really it's trying to advance the intelligence components of robots through simulation, which can hopefully one day translate to the real world. So nice to meet everyone.
Cool. And Hadass?
I was waiting for the last but not least, but hi everyone. I'm Hadass Gazit. I'm a professor in mechanical and aerospace engineering at Cornell. My research is on high-level verifiable robotics. I'm interested in how do we specify behaviors at a high level, typically using logic, a little bit of language, some collaboration with Steffi. And how do we guarantee robot behaviors? So questions of synthesis, questions of verification. How do we think about these things in different types of robotic systems, from multi-robot to modular robots to soft robots, and lately a little more, how do we think about verification and synthesis in the context of human-robot interaction?
Awesome. So thanks everybody for these really great intros. It's really a privilege to be moderating such a distinguished panel. So the first topic that we kind of wanted to cover in the panel, sort of at a high level, is about like the technical development. Like, how do we decide what to work on? How do we decide whether it's going to be good for people or bad for people? And also, especially at CoRL, how can we ensure a diversity of technical approaches and make sure that those approaches get the exposure they deserve and prevent an overinvestment in a particular set of techniques? Of course, the elephant of those techniques right now is neural networks. But if you've been around for a while, you see that these things ebb and flow. And before that, before neural networks were cool, some of us remember the days when probabilistic graphical models were cool. And so I guess I wanted to start out by asking, how do you decide what to work on? And how do we, as a field, prevent ourselves from getting too fixated on one particular set of technical tools? Hadass, I feel like you could say something to that.
I was gonna ask if you're gonna cold call people, and I'm always game. So, sorry for people watching who don't know me. So how to choose what to work on? So I think I'm gonna take this slightly to maybe to different direction that you intended, but I think as an academic, right, the question that is kind of a lot in my mind lately is what do I work on, but also what do I work on, especially since we see the huge kind of developments coming from industry, right? So what do I work on that the space in which I live would be it would be most beneficial for the space in which I live versus large research labs with a lot of resources, right? So I think the questions, and to the second part of your question of how do we not overfit to one technique, I don't know. I'm a little bit out of that world, as you may know, but I don't know, we can talk about that. But I think the main thing is to think about the things. Robotics is so visceral, right? So you can see that, you know, we're trying to make something work and it doesn't. So chopping off kind of why does it not work? Start trying to build think about the different pieces that we need to enable to work, and building on top of all the techniques that we know already how to do compared to, I don't know, 10, 20 or 30 years ago. That's kind of what is the next frontier? I think that's the way to think about it in my mind.
Mm-hmm. Like what's going to be after deep learning?
Nothing.
Maybe I could
yeah, please
continue. So I know two types of motivation. One that I also know from my academic past. I joined Intel relatively recently, and there I think as should be in research, we're driven by curiosity a lot. And in our field, in this where we can connect to people who try to understand how do brain solve certain tasks. There are so many mysteries there. Like, how do we perceive things like color, depth? How do we estimate different parameters? How do we direct our actions to objects? How we do it so precisely? How do we learn so fast? So many open questions. So in that domain of the research, there are just so many open questions. Trying to understand how biological systems solve certain tasks in a way much better than we can do technically, and trying to learn from it, kind of abstract that behavior, try to implement it now on the robot and solve the task. So it's just fascination of research. Now being in an industrial lab, another motivation comes into play. So we need to, in the end, build some products that people would want to have. So we need to solve some problems that people have. So since then, when I walk around, the city, I always look like, what is missing? What is missing? What would be nice to have? What are things, nice to have at home? Like, are there appliances missing? Or, when you watch, in some places, the hard work that people need to do, which is sometimes even don't notice. So there are so many places where automatization would be needed, and it would be nice to have robotic solutions. And then we know all the problems that you face if you try to bring a robot in some real world environment. And then you kind of focus on some particular problem at some point. Yeah, so I think these are the two motivations, kind of curiosity in academia and then usefulness in more industrial research.
Mm-hmm. So Hiram, I think you were talking about like assistive robots in the home. So maybe you want to riff on that a little bit and tell us about like how you think that diversity of techniques could apply in sort of that research domain.
Shall I continue on that?
Or you can, yeah.
Or was it to someone else?
I was saying Hiram because he was talking about assistive robots in his background.
Yeah, then I would say go ahead.
Yeah, well, I think that it's more like you say, Julia. It's like to think out of the box and to get risk for some new benchmarking, some new methods in order to make some different things happening in the robots. But also, I think that unfortunately, this is like market competition, in terms of the techniques that we have. For instance, there are big companies that only look for some kind of these techniques and make some promotion for that. So I think that the better new approaches are validated, and the fiercer that we have to get risk in terms of more diverse exposure we have for the techniques will be happening in this kind of market competition. So, for instance, I try to make this native-inspired computing in order to apply to my robots. So I have developed different techniques that I also prove that those are better than those neural networks of deep learning techniques that are right now. but unfortunately, some people look for those that are already proved and that are in the base of these huge companies. So I think that, it's what I say to my students, to learn to envision novel techniques in order to benchmark and to see what is the potential of those methods.
Mm-hmm. So like to try to figure out like what is, not been investigated enough yet, and then play with it. Yeah. That's awesome. So Conrad, I wondered if you could talk a little bit, like one thing we've been struggling with in my lab is like simulation, and you mentioned that you were studying that, and what I think I've cautiously concluded is that there's actually like a bunch of different simulators that are good at different things, and almost depending on what techniques you're using, it sort of back projects and dictates what simulator you have. Although like going into that simulation discussion, I was like, we'll just pick the best simulator and use it, and that'll be that. So I wonder if you could comment on, how, like, do you think that the simulator you pick ties you to a particular set of techniques, or is there like, are we going to someday have a simulator that is just good for everything and that's that?
Thanks a lot for the question, Stephanie. I think it's really a balance between the amount of computational power that researchers have access to and the fidelity of the simulator itself. Some of the things that we struggle with are realism when it comes to physics-based simulations. And when you going back to a comment that Mark made earlier about just having limited access to training data, what motivated us to explore simulation environments is the possibility that we could have this endless generation of data. But for that knowledge to then translate to the real world, then the fidelity of the simulator has to be comparable to the real world physics in our world, which some may argue is a large scale simulation, but that's a topic for another day. So how do you advance simulations to the point where they are good enough to approximate what happens in the real world? And we have yet to come across a simulator that solves that problem in generality. I think now there are point solutions where you can simulate, let's say, fluid flow in a cup or a bowl, but that generalizing to an entire ocean, I think, is quite limited. So whether or not hardware or software is going to drive that is still an open question.
Yeah, I mean, definitely for us, we've been angsting a lot about simulation and like the accuracy, the physics accuracy, and also the visual accuracy if you're trying to train something with the camera. And then once you have it, like putting stuff in it, putting the world in it so that you can actually try to learn something. It's definitely a non-trivial problem. I think I'm beginning to think like a first-class research problem in and of itself. So Mark, despite your claims of not doing robotics, I still remember the video of the robot doing the learning to balance the the cart pull thing. And it was like showing balancing in like super fast, like with like minutes of trials instead of hours of trials, which I think remains today. Like, I think that idea that like our robots need tens or thousands or millions of hours of training data, and that's really hard to get on a robot to actually learn. I think that's like, kind of the crux of the issue. Did you have comments on that?
I mean, yes, I'm very happy that you actually remember this video.
It was an awesome video.
Yeah, yeah, it has aged. It's been 12 years now since then. But anyways, so yeah, collecting data is hard, especially with I mean, if we look at more interesting robotic problems, beyond the whatever 4 or 5 dimensions, then collecting data is tricky. And then also, data itself is not sufficient. You need to have good data because you can't sample the full state space. it's also not interesting. You want to have data in areas that are interesting or relevant. So finding these areas is tricky. But even if you have data in interesting areas, then even if you have relatively dense data, you also want to have, if you want to use this kind of data to learn some models or build simulators, then what Conrad said earlier, the simulators or the models need to be realistic, ideally. Yeah. So, for example, some realism could be they should follow mechanical laws or physical laws, and not just the black box machine learning models that we often use. But there's a lot of work going on in that area as well. So I think that's quite exciting. I think last 3-4 years, maybe 2-3 years, there's a lot of work coming out on that in that area as well.
It's awesome.
Can I go back to the second part of your question? The how do we not fall into a local minima of methods?
Yeah.
Paraphrasing. I think one of the things is to be very, very explicit about the limitations of the techniques that you're using. And I think there are some communities that are more critical of themselves and some communities that are less critical of themselves. And it's, there's pros and cons to both, right? So you want to have enthusiasm, you want to make, bring students in and show like exciting results and everything. But very, very, being very, very explicit about the assumptions that are being made for that technique, because there's always assumptions being made, and being very explicit about the limitations of those techniques, because there's also always a limitation. That is something that will help kind of guide what is missing, what are the things that can compensate for that. And I think one of the examples that are kind of closest to my world right now is the question of verifiability and the questions of deep neural nets, right? The idea that that when you have model-based, there are techniques you can do that you can kind of analyze what's going to happen, or you have some idea of the bounds you can put on the behavior, which I know people are working on that, but I don't know that there's a satisfying answer at this point in terms of putting bounds on the behaviors coming from these kinds of methods. So yeah, I thought about it and I wanted to bring it back up.
Yeah, that kind of like makes me think about a related question, which we were discussing a little bit in the CoRL steering committee. So NeurIPS recently made a requirement that you have to, in every submitted paper, you have to basically put an impact statement, which I think of as not exactly, I mean, in some degree it should talk about limitations, but also kind of, it's asking the researcher to kind of project forward, and to say, what is this advance for? What can it be used for? What is the impacts it could be for? And I've been trying to decide what I think about this, for CoRL and for RSS, the other conference, our conferences. So I wondered if people wanted to weigh in on that, like what are the reasons to do that, or to not do that, or to be careful of if we go and do that.
I mean, what do you want to see? So, I mean, potential dangers of robots, and good luck with that. I mean, if I look at grant proposals and there is no risk at all by using robots pretty much throughout the bench, then I don't think there's enough honesty in what you can actually do with a robot.
So one of the concerns I heard about it was that it would lead to almost a homogenization of opinions. People would feel compelled to say, a certain set of risks, and there would be social pressure, to kind of say certain things and not say other things, which maybe is good, but you can definitely see it being bad too.
I think I totally misunderstood what you said by impact, because to me it was more of a statement of why should I care about this paper? What is the implication of this? Did you mean impact in terms of risk? Was that, I don't know what the NeurIPS.
Yeah, well, I think, there's what NeurIPS did. And then what I was thinking, maybe I'll phrase it a different way. What I think would be what I was contemplating pushing for, advocating for, is to write an impact statement of the form of, I did this work, I know it really well, and I'm going to try to project forward to say what it could be used for, what areas in the world where people are using, they might apply this technology. And I was thinking that like probably the value judgment on those implications is not part of this. You know, the value judge, like we all have our own values, and that's probably not part of what should be reviewed in the paper, but rather like a factual, it's a projection, so it's not facts, but like a probabilistic projection that's hopefully somewhat based on something we can all agree on. We think this is a possible impact of this work.
I think researchers have a hard enough time, you know, being objective and having their statements quickly expand out of context once it hits the, you know, the mainstream news cycle. I'm sure more than often, many of us are aware of those papers that, you know, maybe were done on mice, very preliminary. And then the next thing you know, there's this headline of this discovery being applicable to humans. And, you know, I think we're sometimes as a research community naive in the sense that we get to control the narrative of our research. So, you know, there could be concern that statements or requirements such as that may further exacerbate these challenges that already exist in society.
Yeah, you can definitely imagine a reporter taking a projection out of context and having that go south. Yeah.
I mean,
and also it might be a good idea to introduce some kind of validation of these statements, because it's easy to write down and project, you know, what the impact could be, but will we review it next year and check? You know, maybe then one could, you know, look at the papers from last year, see what they said the impact would be, or like, you know, 10 years ago, and just validate to see you know, how founded those projections are.
we actually found it sometimes quite hard to write these impact statements. You know, depending on what kind of work you do. You know, if you do theoretical work, then coming up with an impact statement of is whatever the next bound, regret bound on some learning algorithm, then it's quite tricky, and it feels also a little bit like we are. I don't know, I don't want to say we turn papers into grant proposals, but this is kind of like...
We kind of do.
You know, well, we are, but it's not particularly appealing to do this. I find it painful to write impact statements in general. But I think before we think about, you know, forcing or encouraging people to write broader impact statements, I really want to also support what Ada said earlier on we should be honest about what we can actually do, and then rather have a discussion section on strengths and weaknesses and limitations of your whatever you've done in your paper. I think that would be much more beneficial to the research community than before we have an impact statement. I would rather see a section on that.
Mm-hmm. Yeah, I like that idea. I was thinking about like how, like for certain types of papers, I like know what weaknesses to look for, and I find that, and then I find them, but it's not like they're called out. They're like embedded in the paper. You have to find them out. And
the question is also like, what do you want from a paper? Yeah. So when let's say when I read a paper, I want to learn something. Mm-hmm. And the worst papers, or for me, the worst papers are, oh, we try something out, it works. And then, but there's no like explanation of like why it works, when it works, how it works. Yeah. I mean, the how kind of like how is often in there, but it's I want to learn something, and these kind of like discussions are the most interesting thing for me in a paper.
Yeah. Okay, so I want to move to kind of the second half of the moderated part, although we're already more than halfway through, which is sort of the art of research and trying to think about like who does the research. And you know, along the pathway of becoming a researcher, there's a lot of sort of gateways, you know, ranging from getting into an undergraduate, now to getting into a PhD program, you have to write papers, right? And then, you know, all the way through to, you know, finishing your PhD thesis, doing your qualifications. And something I've, you know, I personally owe a lot, you know, Nick Roy's here on this call. Like I would not be here today as a professor without Nick. Like, you know, he literally changed the trajectory of my life through his mentorship. And
I'm not sure I
I think.
agree with that. I was a happy bystander as you took off like a rocket. But anyway, continue.
Well, we can. Anyway, I remember the day you pulled me in your office, and my life went on a different track after that. But anyway, so that's been really valuable, and I can't say how much that means to me. But on the negative side of that, we do have this kind of like, the people that Nick writes letters for, I read those letters. If Hadass writes me a letter for a student, a recommendation letter for a student, then I'm going to look at that student 3 times, and it's going to be hard for me to not admit them, right? We sort of have this like community of people, and we know each other and we trust each other, and it's good, and I love you guys, but I also worry that it's exclusive, that it's preventing really strong students who don't have the opportunities that I had and the mentors I had at the place that I had, taking the path that I had. So I wonder if people have reactions to that. Like, is that a real thing, and what can we do about it?
Well, I mean, it's fairly straightforward, right? So it's look at all the applications as if you wrote it, right? It is as if, of course, we can't do that for everybody, because, if you get 500 or 1,000 applications, physically, you can't actually go through all of them. But I think making sure we're not dazzled by paper in undergrad, for example, or coming only from the top 5 institutions, or whatever top 5 means, and looking for potential and not looking for accomplishments necessarily, which is easy to say, but also, I mean, really one thing to do is to come up with a really realistic set of rubrics in which you say, okay, these are the qualities that I'm going to look for in the letters and in the grades and whatever. Maybe drop the GRE, because maybe, it's definitely a barrier there. And that is on one hand. On the other hand is recruit. Go and look for places that maybe you typically would not get people from, and recruit there, right? So. Yeah.
Do other people want to weigh in, or should I call on you? Hiram, do you have anything to say?
Well, yeah, about this this issue, I guess it is very interesting to see the work from students or for the people that you are getting into your lab, because about the you are adding these skills for your lab and for your ongoing project. So this is one of the main important things, at least for me, when I have to choose what students are going to be in my lab. Is like to see, well, this has to this student works with all these techniques, or maybe it has some strengths on that maybe could be a push forward all the work that is going to work together with all my other students and researchers. So I think that part of these kind of skills are involved in this collaborative way in order to make multi-diverse ideas to get more enriched to the project. So for me, this is kind of the main part for trying to look for new students or for new people to labs.
Yes, maybe I can say a few words.
Yeah,
I think it's a really challenging issue, because I think it's a human natural tendency, right, to work with people who are like us, who are similar to us, who maybe come from a similar school. It's easier, right? The communication is so much easier. You say half a word and the student already picks up and knows what you mean. So I think it's very natural and easy to go this way, right? To take people from other labs that are similar to our labs and so on, and to kind of work against it requires maybe some structures. So on a more institutional level, like establish some exchange program with some unknown lab in some unknown country, and get the students from there for half a year or a year, have some exchange program, for instance, or some other way. For instance, in Zurich, where I was before, we had this international master's program where explicitly we wanted to have international students from all over the world. We wanted to have this diversity. It was one of the criteria. And then you get all these very different people. And it's challenging, but also, of course, very rewarding and enriching for everyone involved. So it's definitely worth it, and gives kind of an additional dimension to work. It's not only publications and producing something, not only all these competitive things, but also just having richer environment where maybe also different ideas can become fruitful.
Mhm.
All right. I'll chime in.
Awesome.
Go ahead, Hadas.
No, go ahead. I'll follow you.
Yeah, so to Stephanie's comment about, and she actually used Hadassah as an example of a filter. I think there's certain aspects of academia that encourage risk aversion. So if, a new assistant professor is on the tenure track, are they going to take the risk of, welcoming a student that has maybe just as much or more potential as a student that Hadass recommends? Or are they going to, take the safer option, especially since such a decision could be the make or break in a tenure decision? So I think there's certain aspects of the reward structure in academia that encourages these types of actions, coming from a reinforcement learning metaphor. So.
Yeah, but I think I 100% agree with that risk aversion, especially early on. And to some extent, we should, assistant professors should be risk averse in that sense, right? I think what we need to be careful with, I think this is what kind of Yulia was saying, this comfort, this fit, this kind of someone who thinks like me, looks like me, acts like me. That is something that we should actively work against, because that is not, more ideas come from more points of view, right? So your lab, anybody's lab, will be a lot richer in terms of the research that it does, the perspectives that it takes, the interaction it has with the people that it's working with, if it comes from multiple points of view, not just from one. So being very conscious of the fact that that it's probably in your best interest to get outside of your comfort zone in terms of whatever dimension you want to look at. It's something that's you have to consciously do. And if you look around and everybody was trained the same way as you and look like you and talk like you, then something is not quite right, because you're in an echo chamber. So yeah. Okay, kind of basically agreeing with the two of you, but with the added caveat of when you're starting out, to be conservative in terms of risk.
I mean, the sort of risk averse is exactly how I think about PhD admissions. Like if I see somebody and they have a good letter from Nick or you, like, it's undeniable, like that's less risky, and so related to that, I guess what I want to know is like, how, like, is there a way to have my cake and eat it too by improving the diversity and inclusiveness of my technical networks, so that I'm getting a letter from somebody I trust, and that person is, somebody who thinks differently and looks differently and all of that stuff. What can I do? What can we all do to increase the diversity of our technical network?
I find
Mark.
letters utterly useless. They depend a lot, and this is, I think this is reinforcing actually the bias or the risk aversion or whatever we want to call this. If there's a letter from somebody in the States, we put a high discount factor on the letter to start with. If somebody sends a letter from Africa, the letters will be completely different. So I have seen a letter for a graduated PhD student from his PhD supervisor in I think in South Africa, and the support letter says, "I believe he is capable to graduate." That is a support letter you would get, whereas in the US you would get the opposite, and in Europe is somewhere in the middle. So that's the reason why having these letters is already, I think, is a bad thing. I mean, what are you expecting in the letter? You're reading something between the lines, but then you need to have to understand also the context of the letter writer and the context and the circumstances of the applicant. So I find them not particularly helpful, and getting rid of letters also saves us a lot of time. But what I also wanted to mention is that I think what we should be looking for in applicants, and that's not only PhD students, but also when we look at, for example, faculty or whatever, anywhere applicants, is potential and not so much opportunity, right? So having a supervisor in one of the top universities is opportunity. That may be coupled with potential, or is often coupled with potential, but there's also a lot of potential in places which are not, Stanford, MIT, Oxford, Cambridge, whatever, right? And so finding these people is harder. And I think if we want to increase diversity, then we need to work harder on this. I mean, it's easy to find the good people from the top universities, but I think we should be aiming for finding the top people from the crap universities.
Mm-hmm.
If I could just jump in real quick, just to respond to Mark. So Mark, I completely agree. It seems like what we're describing here are features of a classifier, where let's just call it a binary classifier of successful PhD and not successful. Some of the features that we use to lead to this decision are more readily observable. I would love for us to be able to evaluate, the experience of a candidate as a decision feature to hire someone, and maybe we can promote this more by having more, undergraduate, master's research experiences, across the board, where students, before they even consider applying for a PhD program, engage more in research labs and research programs, whether or not it's a summer program or during the semester, because I think then that gives this type of temporal understanding of the potential of this student, as opposed to just looking at a CV or a letter or some other very subset of features.
Mm-hmm.
But I think those experiences have to be funded. Otherwise, we are there's this type of privilege that people from lower income situations just can't do it. It's not that they don't want to; they just can't. So we're losing a lot of people that could benefit from these kind of opportunities, because they're typically require you to pay. Summer programs for undergrads, not so much grad students, but. Yeah, so that's kind of another thing, that giving those opportunities and making sure that those opportunities can be actually taken advantage of by people who should be able to do that.
Okay, and I think Nick had his hand up.
Yeah, I'm not formally a panelist. I hope it's okay that I'm crashing this, but I completely agree with what Mark and Conrad said, which is that it is absolutely work. And to Conrad's point, it's work that you got to do before the application deadline. So I think, Conrad, if I can summarize what you said, is essentially waiting for the classifier, waiting for the data to be uniformly distributed. When it gets to the classifier, it's already too late. And you need to be putting the work in to find these people. So things that, this is by no means, I don't in any way want to suggest that there's an answer, but things that we're doing, at least in Aerastro, is there's the National Name Exchange, where people can, especially underrepresented populations, can register their name as being interested in an area, and then we contact them and encourage them to apply. We run information sessions throughout the fall, explaining to people who come. This is one of the very, very narrow and small ways in which this pandemic has actually helped, in the sense that it's normalized Zoom engagement. So it's much easier to get face-to-face contact with people that you normally wouldn't see. Universities, we've never had in my department an applicant from Spelman. We've had 2 from Howard. This is, completely unacceptable to us. And so we're trying to, set up information sessions to reach people from universities where we don't normally have, and they're not necessarily good or bad universities, just places where we don't get applicants. And so trying to build that up. I think is really important, but it is sustained work where, year in, year out, we now have a calendar of like, this is when we send out these emails. This is when we run the information sessions. These are the conferences that we have to go to. I don't in any way want to say we've turned the tide, but at least we're getting more engagement before people even apply. And I think that's where the work is, and it is work.
I think the work is also after the retention aspect of it.
That's such a good point. Yeah.
That people who come from maybe universities that emphasize different things. For example, I know Chad is on a crusade of linear algebra. There are places that don't require linear algebra. You come into to programs like in the people represented here, and they do poorly. So it's a matter of also putting in things in place that support students after they're there, which I think as a community we don't do quite as well. So across the maybe the R1 universities in the US.
So this combines Hadass as your funding, and then Nick, your work. It seems like it's both money and effort. And sometimes I wonder, it seems like funding agencies are already, and universities are already constrained. So I wonder how much industry could do, or governments, and for us as a society to see this as a positive thing. I don't know if the owners should just be on faculty members. It seems like this should be a societal effort, if that is we value this.
Just a quick comment on this. So here in the UK, there's actually a lot of support from industry for these kind of measures. So there are companies saying, oh, we are going to give you scholarships for undergraduate, for master students, for PhD students, even for postdocs, if you hire diversity candidates. Not the typical people that you would normally hire. And so they are kind of like pushing actually the universities a little bit around to get their feet off the ground to get something done. The government here is not great in general, actually, but also not particular with the in supporting these kind of measures.
Cool. So I want to make sure we have some time for questions from the audience. So we've cut into some of that time with this discussion, but it was cool and important. So, so for those of you listening, you can use the Zoom webinar Q&A to post questions, and I see that there's a few in there already. So I'm gonna ask one of those questions now, but please feel free to post more. So this is a question from Raya, and again, I'm sorry if I'm saying your name wrong. Robotics is arguably 10 years behind a field like computer vision in terms of the pace of development. So what are we missing? Are we missing like data sets and benchmarks, or algorithms, or robots, or what? And anybody can just chime in.
Okay, maybe I can chime in. So I think computer vision is I would ask to excuse me, but it's a much smaller and narrower field, right? That's just image processing. Just one modality, one sensor. It's of course very sophisticated and rich modality, no questions asked. But on the robot, we have all the other sensors. We have, auditory perception. We have tactile. Tactile, we don't really know how to well integrate it, know how much of tactile we want to put on those hands. We have, force sensing and position sensing. We have motors. We have motor control. We have all the geometry involved in motion generation. We have kinematics and dynamics. We have to coordinate it all, maybe link it to vision as well, but then at a quite different pace than what you do for computer vision. We cannot wait seconds. We cannot wait minutes for sure, but even seconds are too much, right? We need milliseconds to control. So it's just much more interdisciplinary, more complex and rich field, right? And it has all these materials and the hardware involved that needs to work and be robust, and all the mechanical devices. It's just so difficult to compare. And in terms of benchmarks, so for computer vision, this field was lucky and unlucky that all these benchmarks emerged, all these huge data sets of images labeled that you can use to compare your approaches. In robotics, it's so much more difficult to get something like that because every robot is different. Even if you just focus only on navigation, let's say only mobile robots, even there, you have robots that are holonomic, non-holonomic, all kinds of platforms with all kinds of constraints, different motors involved. How are you going to come up with any benchmark at all? And just the complexity is immensely larger on a different scale, I think. So I don't really agree that, or maybe that's the reason why we are not on the same pace, because we are solving quite a much more challenging problem.
Sure, sure. Hiram, do you want to chime in with anything on that question?
Yeah, sure. We use very different techniques from computer vision for our robots, but mainly those are doing on simulation. When we are trying to make it unreal, it is very difficult, and the terms of complexity of the hardware, the software, all the computational resources that we need, it's especially important, and it's very challenging to really make it for real. So in this case, I think that we need more and more things on electronics in order to make it more powerful, to really put into action into those robots.
Cool. So another question, which I was actually kind of wondering about too. So this is, do you believe there should be a subject exam to evaluate the applicant rather than just reading his letters or statement of purpose and stuff? And yet, so this is like GREs are bad, and we know they're bad. But maybe though, I don't know, like, could we have an exam that wasn't bad and that was objective, and maybe that would help?
Exams are bad. All exams are bad. I'm going to go with that.
All exams are bad.
If I could remove all exams in the curriculum, I would do that. I mean, they're a necessary evil sometimes, but it is. What would you even do as a subject exam for robotics, right? What it is so broad, or I don't know if actually I don't know if the intent was robotics, but there's definitely a trend.
Robotics.
People are getting rid of the subject, definitely the specific subject exam for GRE. So physics doesn't, I don't think it's being used anymore. People are moving away. Departments are moving away from GREs in general because they're expensive. So that's a barrier, and you can prepare for them in a way that's not equitable. So I see kind of this being the same thing, right? So yeah. So my perspective is no.
So I think the question is also, what do you actually want to measure? So once you figure out what you want to measure, then you can think about how to assess or evaluate this. And I think one of the things we should be, considering a bit more carefully when we hire, and I think that also goes with some of the other questions in the chat, is that we may want to look a little bit beyond academic credentials, and if we want to, so I would like to see somebody who can kind of like get started, but then kind of like the gradient is very steep. So again, like, what difference does this position, whatever that position is, make to the candidate's life? What does it enable? But we also need to understand circumstances of the applicants. So that means social. When I say social background, I don't necessarily mean. So I mean more like personal background. Do I have to care for my family, my siblings? Do I have like 2 jobs to keep myself above water? So these kind of things play a role in practice. When I don't know how to, whether an applicant should necessarily write this in their application, but these are things that matter, and that also explain a little bit more what the situation of the applicants are. And these things are, I think, it's very valuable information. And then, I don't know, somebody is asking what should applicants be doing better? So a lot of questions I'm getting is, how do I get in touch with a potential supervisor? I don't even know how to get in touch with them. So I think what we what we can do is we can do much more mentoring of students. For example, these conferences here, they are great opportunities to run mentoring sessions. So that has happened in a bunch of machine learning conferences. I'm not sure whether it's happening here as well, but just set up a Zoom or whatever meeting, an hour, announce this through some chat, and say, you know, if you have any kind of questions related to whatever applications for grad school or whatever, just Zoom in and ask questions, and we're going to discuss this. So maybe that's something we can actually do with relatively little effort.
Cool. So we have about 5 more minutes. So I wanted, and then there's more questions, and we're going to have time to get to. So I encourage you all to go to the GatherTown meeting, which is right after this, where you can, it's like this video chat thing with spatial stuff. So you can walk around and talk to people kind of like a real conference. And you can ask, you can talk about the questions there with the panelists. But I wanted to finish up by just asking everybody to think about kind of like, if you know, what are you going to do? Like, what actions do you think you might take to address some of the challenges that we've discussed today? You know, what are concrete steps that you could do, or that I might do, that we all might do?
Can I say something different?
Yes.
And then I'll answer that. I'll try to answer that. Sorry. I wanted to actually start out kind of the first time I said with this, but it didn't work out. I just want to acknowledge the fact that we didn't mention this here. I don't know if it's been mentioned at CoRL. We're in a pandemic, and we are in if you're in the US, it's been also a very exhausting political climate, regardless of your opinions. So it's been very, very exhausting. And I just want to, you know, especially if there's younger researchers out there, this has been really tough to be creative, really tough to be productive. Really, it's just been really tough. So this too shall pass. We will be creative again. And this is talking to myself as well, but just kind of, I wanted to acknowledge that, because it is, sometimes it's very easy to think that everybody's just plowing away and working away, and oh my gosh, they're going to get so much done because they're at home and they don't have any distractions. So that's not the case. That's not the case for almost anyone that I know. So yeah.
+1.
So what?
+1.
Yeah. +1,000. Yeah. So I just wanted to mention that. But to your point, I think being intentional about how you do your work and how that affects how your work affects the world is something that you have to keep in mind all the time with the people that you work, or the problems that you choose to work on, or, you know, we see this a lot in tech these days. So I'll stop.
I'd like to just add that, you know, we need to have more events like this where, you know, individuals from different backgrounds and research interests come together to discuss these issues. So I'd like to thank Victoria for extending the invitation to me. I would encourage all of us here to go a step beyond just this panel and explore ways to collaborate. So I will be at the social gathering, and hopefully we could continue the discussion and find ways to build upon, you know, these great discussions we've started here. So thanks again for the invitation.
Hiram? Yeah, thank you.
Yeah, I also agree with all of you. No, we need more discussion on this inclusiveness for robotics. Even though I think that we have to constantly evaluate how robot development for people is doing in order to really engage all the opinions and all the ideas that many people have, in order to make a more not like a general solution for robotics, but that the solutions that we do with robotics really engage all kind of people and all kind of ideas. So I was thinking when all this panel discussion starts, about how to make some kind of human rights-like framework in order to make this really works for robot design. So I think this is something that we could really think about it, and to make sure that diversity and inclusion really could solve very different problems, not only in robotics. Robotics is a very challenging opportunity to make all our solutions to make applied, but also in real life, how to make this diversity and inclusion works for all of us. So thanks for the invitation.
Julia?
Sorry. Yeah, so I agree with everyone. So I think one of the kind of mottos could be, we should think globally, but then act locally. So everyone kind of in the field of your own responsibilities, just try to follow this kind of goals that we set in terms of diversity, in terms of human resources, and also the topics that we work on. So what I personally always try to do is not to follow, the trends and the rewards that are put outside. So whether that's publishing, H index, what's not, I have some goals and visions, and I just follow them. And luckily, we live in the world where I'll do fine. There we won't perish, right? If you don't, follow the trends prescribed by our society, like academic or research society. Yeah, so that's kind of my motto. Everyone does whatever you can.
Awesome, thank you. And Mark.
Okay, given that I think Sim2Real is going to solve our simulator problems, so I think that's no longer an issue then. So the things I'm going to do in the, well, not future, but I've been working on this stuff is more on the hiring and retention side of candidates. So I want to give people a more or less an equal opportunity to get into a PhD program. So what I'm trying this year is collecting applications and not look at them, and then up to, I think, maybe next week or in 2 weeks, and then go through them all at once to kind of like take a little bit of the bias out. I don't ask for letters because, yeah, I said earlier, I don't find them useful. But then there's also this other thing of, I think, which is even, I think, harder, is this thing of creating a supportive environment that helps people to, I don't know, to grow and to succeed in their lives and to fulfill their potential. And I think that's even more challenging because that is, requires a lot of change and a lot of thought. So that's kind of like what, at least my priorities are in that regime, in that area.
Awesome. Yeah, I'd sum that up, and also what Haras said with the word compassion. We should all have compassion for each other. So thanks everybody for coming and participating in this panel. Thanks to the attendees for your great questions. I did stick the GatherTown link in the chat, and I see Victoria also just stuck it there. So we hope to see you there immediately after this. So thanks again.
Thanks, everyone.
Later.